Assalamualaikum dan salam sejahtera semua. So, ini adalah video untuk bahagian pertama, chapter 10. Wave is defined as the propagation of a disturbance that carries the energy and momentum away from the sources of disturbance. Mechanical waves is defined as a disturbance that travels through particles of the medium to transfer the energy. Okay, look at this diagram. Okay, someone plucked the string. Okay, so it produces wave. So the up and down motion of the rope is perpendicular to the direction of motion of the wave. Okay, so the string produces string wave. Properties of waves. The particles oscillate around their equilibrium position but do not travel. Examples of the mechanical wave are water wave, sound waves, wave on a string or rope, wave in a spring, and seismic waves or earthquake waves. So all mechanical waves require some source of disturbance, a medium that can be disturbed, and a mechanism to transfer the disturbance from one point to the next point along the medium. Progressive wave is defined as the one in which the wave profile propagates. The progressive wave have definite speed called the speed of propagation or wave speed. The direction of the wave speed is always in the same direction of the wave propagation. There are two types of progressive wave, which are transverse progressive wave and longitudinal progressive waves. Transverse wave is a wave in which the direction of vibration of the particle is perpendicular to the direction of the wave propagation, which is the wave speed. Okay. Transverse wave is a wave in which the direction of vibration of the particle is perpendicular to the direction of the wave speed. Okay, this is example of transverse wave. Then this is the particle vibrate in this area. Okay. Okay, like this. So direction of the propagation of the wave is perpendicular to the direction of the wave propagation. Longitudinal wave is a wave in which the direction of vibration of the particle is parallel to the direction of the wave propagation, which is the wave speed. Okay, longitudinal wave is a wave in which the direction of vibration of the particle is parallel to the direction of the wave propagation, which is the wave speed. So this is the example of longitudinal wave. Okay, is direction of the vibration. Okay, so the particle vibrate. Okay, this particle vibrate like this. So direction of the propagation is parallel to the direction of the wave. Okay, so direction of the vibration is parallel to the direction of the propagation of wave. Learning outcome 10.1a. Define wavelength and wave number. So figure below shows a periodic sinusoidal waveform. Okay, so this is the amplitude. Okay, this is crest or peak. Okay, at this point is the crest or peak. Point C also is crest or peak. And then point S and point T is the trough. Okay, of the waveform. Okay, So from crest to crest is 1 lambda, or from one trough to one trough is 1 lambda, or for point P to point Q, which is in one cycle. Okay, one cycle is 1 lambda. Displacement. Y is defined as the distance moved by a particle from its equilibrium position at every point along a wave. Okey, dalam chapter 9, displacement simbol adalah X. Okey, dalam chapter 10, simbol untuk displacement adalah Y. Okey, dan X adalah distance. Okey. Amplitude A. Amplitude A is defined as the maximum displacement from the equilibrium position to the crest or trough of the wave motion. So Y maximum equals amplitude. Frequency is defined as the number of cycles or wavelength produced in 1 second. Okay, it is how many oscillation that can be made in 1 second. Okay, the unit for frequency is hertz or per second. Okay, and the formula is F equals 1 over T, where T is the period. Okay. Period is defined as the time taken for a particle in the wave to complete one cycle. It is time for the wave to travel one wavelength. Okay, and the formula is period T equals 1 over F, where F is the frequency. Angular frequency omega is defined as the rate of change of the phase of sinusoidal waveform, and the unit is a radian per second. And the formula is omega equals 2 pi over period T, or omega equals 2 pi times frequency F. Okay, so angular frequency omega is also known as angular velocity or angular speed. Okay, wavelength lambda. It is a distance between two successive identical points on the wave. Okay, wavelength is distance between any two successive identical points on the wave. And it is also the distance between two successive graph or trough. Okay, distance between two successive crest or trough. Okay, wave number K. K is the number of wave exists in 1 meter. The formula is K equals 2 pi over lambda, where lambda is wavelength. The SI unit of wave number is per meter, and it is depend on unit of lambda. If unit of lambda is meter, then unit for wave number K is per meter. If the unit of lambda is cm, then unit of wave number K is per cm. Phase angle phi. It indicates the position of the particle at distance x0 in the wave when the time t0. If the displacement y is 0 at x0, t0, then the phase angle phi is 0. It also shows the relationship between the vibration of one particle to another. Okay, if delta phi is 0, that means it is in phase. If delta phi equals pi over 2, that means it is anti-phase or out of phase. Equation of progressive wave. Figure below shows a progressive wave profile moving to the right. So general equation of displacement for progressive wave is given by y equals a sine omega t plus minus kx. Y equals a sine omega t plus minus kx. Where y is the distance moved by a particle from its equilibrium position. X is distance of particle from the origin. A is the amplitude of the wave. K is the wave number. Omega is angular velocity and T is time. So dalam equation ni ada dua karakteristik yang mana y equals a sine omega t represent the particle vibration. Okay, y equals a sine omega t represent the particle vibration, and y equals a sine kx represent the wave propagation. Okay, so in this equation, unit of y, okay, unit of y depend on unit of a, amplitude. Okay, and then unit of k depend on unit of x. Okay, so dia akan samalah, unit x dengan unit k akan sama. Okay, kalau unit x dalam cm, jadi unit k adalah per cm. Okay, dan untuk y dan a mesti unit yang sama. Okay, so kalau unit y dalam cm, so amplitude pun dalam cm. Okay, direction of wave propagation. The wave propagates to the right, so the equation is y equals xt a sine omega t minus kx. To wave propagate to the left, the equation is y xt equals a sine omega t plus kx. Okay, so kita akan guna yang ini, konsep yang ini. Kalau minus kx maksudnya wave propagate to the right. Okay, plus kx maksudnya wave propagate to the left. Okay, so setakat ini dulu. Thank you.